Hello community! You know the old saying, if we have enough training data, we can build an AI system around it. Let's have a look. Imagine you want to have the code for an AI system for a natural language input prompt, and the output should be an API call or your complete call. So here we go. Let's say I have my natural language prompt. I would like to translate. This is an amazing example from the English to the Chinese language. And I don't just want the translation to happen. I want to see the coding system that I have to apply in AI to get the solution. So let's do this. So what I get is I have now a domain, natural language processing, text-to-text generation. This is great. I have my API provider, this is HuggingFace transformer library, and I have a specific API call. This is my model. I use here T5 for conditional generation from pre-trained the Google Find T5 XL model. I get an explanation what all of this is. So we import the necessary components from the HuggingFace transformer library, the tokenizer. We have a model checkpoint, the input text is given, yes, and everything is translated. And a string is returned. And then, and this is nice, I have the code sequence. Look at this. This is really the code that you insert into your PyTorch notebook and you can execute it, and you have a system that does the translation, whatever is your input string for you between the languages specified. You have then the print of the response. Beautiful. Now, isn't this nice? Second example, an object detection. Let's say the task is to build an AI system where my task is now in my natural language. I want to build an object detection system that can detect objects in an image. For example, my cat JPEG image, and I have the input here, the file. And now look at this. This is what I get. Again, here from API provider is HuggingFace transformer. The domain now is computer vision object detection. My API call is here a specific object detection from here, a specific model. I get an explanation what's going on. Oops, till here. And then, as you can see, I have again the complete code sequence here. And I think this is amazing. So we have now the ability for everybody to just say, hey, I want to build an object detection system. And the system code is generated for you, referring here to special API provider. And in our case, it's HuggingFace transformer. What is this system? How does it work? Who generated the system? And how you can use it if you are a developer. So coming back, I want to show you here some news. July 21st, 2023, that GitHub Copilot Jet Beta is now available for every organization, for every paying organization to try it out. And you say, amazing, beautiful. So have I been using this GitHub Copilot? No, I haven't. But what is interesting that GitHub is saying now, hey, it is such a perfect tool. Look at this. With this GitHub assistant, this means 10 days of work can be done in 1 day. 10 hours of work can be done in 1 hour. 10 minutes of work done with a single prompt command. This will allow your developers to amplify their truest self-expression. So this means if you have 10 developers for your specific company task, imagine with this tool, you only need 1 to 10, 1 developer. Isn't this amazing? So every CEO can now calculate exactly the cost savings. And with this easy published by GitHub here, 10-to-1 ratio, you can immediately calculate how many cost savings you can usher in. Now, on the other side, if you are the developer, if you are one of 10 developers, and you are the only developer left, you better know how this system works, because your future and your career and your job will depend on the performance of this specific GitHub AI tool. welcome to my video. So let's say, where are we? A lot of developers put new code daily, new code on GitHub for free. So they are the people that help Microsoft reach its new annual recurring revenue target of $10 billion from AI. Because, you know, those open platforms like GitHub are great for the community to learn. And knowing this, Microsoft bought GitHub for $7.5 billion. And now Microsoft is also part of the open community. And Microsoft owns the company that owns the open platform, where all the coder puts their code for free daily and provide new data for the market. And then Microsoft, which is not a charity, sells now this new GitHub AI assistant to companies. So isn't this great? Or maybe you choose to publish your new brilliant and genius AI models and all the new data sets that you created from new open source data on another open platform like HuggingFace that Microsoft has not yet bought. It is all completely up to you. So, and now to something completely different. Imagine we have here our GPT-4 systems or any LLM, and you have now the task that you give to GPT-4. Hey, I want to travel from Rome to Milano by car and visit some nice Italian restaurants and some beautiful historic sites. Now, isn't it great that we have here for the Italian hotels, the car rentals, the restaurants, the travel guide, all those companies have APIs we can connect to. And there is maybe a system where you have long chains, and those long chains connect currently here LLM system with some specific API system. And you might ask, what happens if GPT-4 has not really been trained enough on creating and coding those API interfaces in a perfect way? So what if we take just a small large language model, a 7B model, and we trained it on a commercially free MPT model or a Falcon model, and we trained this expert system exclusively on API. So we have a small but dedicated professional API Connect LLM. And you know what? Since it's an LLM, we can talk to this subsystem, this expert LLM, in our natural language. Now, isn't that beautiful? So instead of those long chains where everything goes, we have now enough data for a trained LLM for an API interconnect between our GPT-4 system or any other LLM and those dedicated APIs. And for this LLM, we use here a specific, let's say a Falcon 7B model. This LLM will do the job for connecting GPT-4 with all other APIs in the world. So how can we do this? Welcome. Now, of course, this example is a beautiful dream example because I have currently 38 degrees Celsius here in my room. So I'm dreaming of going to Italy for some holidays, but of course we're here in a YouTube video about learning how to code. So we are focused on a complete different application. We go here for an API to PyTorch HUB. We go for an API to the TensorFlow HUB. And we go for an API where all of the information of the HuggingFace platform is available. So nothing with an Italian holiday, but we are back to work. Welcome! So we have now here the intention to create an expert API LLM only exclusively focused on creating the perfect API calls. And if we have enough data, we can train an LLM on this. So let's do this. And you might say, hey, wait a second, there have been all your shorts out lately where you say here, fine-tune Llama 2 in 2 minutes and everything here is available, of course, on HuggingFace, so there are the scripts. So why we have to do this? So can we really take here advantage of everything the interconnect modular elements on HuggingFace? Well, and the beauty is yes, because this is exactly the model I showed you at the very beginning of this video. What I get back from this Falcon 7B model, for example, is exactly this. I showed you my API provider is HuggingFace transformer. The domain was the computer vision object detection. My specific API call was here for an object detection for some pre-trained model vision transformers. I got an explanation what's going on. And remember, I get a code. For example, for this system, I get this specific code. It's not beautiful printed, but you understand the process. So let's look here at HuggingFace. You notice this is the HuggingFace interface. We have here to choose the task from multimodal, from image to text, for example. And then we get here all the different models. We have 200 models for image to text. Or we go to computer vision and we say image to image. We have 159 different models. Or let's do a natural language process. Text classification, no, text generation. Text generation, beautiful. And we have here, for example, 16,000 models. So if we take now the, I don't know, the top 20 models, the top 50 models, and for each model, like here, big science, we read now in this specific API, this model card. So we read in all the information that is presented to us, the use, the direct use, out of scope, misuse, whatever. We read everything that we need to learn about this. We have here specific website links that we can go to and we have the files and the version that are available for us. Beautiful. And yeah, you have community response. So you have a lot of information here going to HuggingFace and getting some API points back. And you have a lot of information, for example, here, Amazon SageMaker for optimizing the training. If you want to deploy it, you have your inference API, your inference endpoint, wherever you go. And if you want to use it in the transformer library, you have here, for example, code examples. So isn't this beautiful? The amount of information on HuggingFace is amazing. Let's use this information. So coming back now, this is where we are. This expert API LLM returns now the perfect API call that will accomplish the task that I now ask GPT-4 to perform for me. I said in my natural language, identify all objects in an image, choose the optimal vision transformer model available, and show me the code, what code I have to implement in my PyTorch environment, or TensorFlow environment, or whatever you have. And this little expert API LLM will do this job for us and return the code. How is this possible? What are the training parameters behind this? What is the general system architecture, how you train such a code LLM? Welcome to your new research publication, 24th of May, 2023. I've been waiting for months to show you this, but now finally, with the beta release of GitHub, I can now show you how these systems work. Now, it's a pure coincidence that we have here Microsoft Research integrated here in this research proposal. So 3 months ago, this was published, of course, by UC Berkeley, beautiful work Berkeley, and Microsoft Research. You see, the infrastructure of Microsoft Cloud Compute Center is almost universal. So here you have your Arxiv link if you want to read this beautiful publication for yourself. And we are talking about Gorilla, large language model connected with massive APIs. So we do not need any long chains for this. But now we have an AI system, an LLM system. How does it work? As I told you, GPT-4 is not really trained for this job, because this is a very specific API and interface job. And if you give here GPT-4 the task to do this, no. So for example, the prompt here was, help me find an API to convert the spoken language in a recorded audio to text using the code available on TorchHub. HUB. You see, GPT-4 was not trained for this, Claude was not trained for this, but here we have our small little 7B Gorilla system that was only trained on this, and it succeeds. Now, what a coincidence. Of course, if you compare this now as the authors of this study did to other systems, to a Llama system, to a pure GPT-4 system, to a Claude system, to ChatGPT. Now you see that here, given our accuracy y-axis and the x-axis where we have the hallucination from 0 to 100%, Gorilla outperforms all other models because we have almost no hallucination and we have a very high accuracy on the particular task of API. So, yes, you can have a look at these beautiful graphs, but this is it. I have my human prompt and I tell the system, hey, invoke an image classification model that you can choose that uses less than 10 million parameters but maintains a specific accuracy of at least 70 percentage points. Now, this prompt that I give to GPT-4 is really a substantial challenge for any LLM to accurately interpret and respond to. So GPT-4 takes this prompt and says, hey, I have an expert AI, a little expert AI that is exclusively trained on APIs. So GPT-4 forwards exactly this human-like prompt to our Gorilla AI system. And here we have now something very special that the researcher did. They said, hey, let's do a novel approach. And what we do now is, so we have this human prompt. What if we do now a two-step process? At first, if we go for a specific API, we have now that we retrieve the most up-to-date API documentation for this specific API. We download it and we store it in a database. So then we know exactly how to use this interface functionality, what exactly is the code, what exactly are all the functionalities I can use this API for. And then I do some simple prompt augmentation that you know, that you love. So to the original prompt, invoke an image classification model. We augment now here this prompt with use this API document for reference. And then we just provide here a JSON file. And in this JSON file, the API documentation explains everything how to do this. So this is now the training step here for our little API LLM. It learns this in a fascinating way and it has some benefits. If you train now this LLM on these augmented prompts, this helps the model to understand how to use the API documentation. Also, if you update the API documentation from time to time, that the updated information will be fed back into our API LLM system. Can handle beautiful these updates, reduces the hallucination errors, and in summary, those retriever-aware training, where we use here a specific API database, a classical database, nothing fancy, is a method of training here our API LLMs that involves augmenting here our user prompt with the API documentation. That's it. Two-step, simple, trivial, forward. If you want to see here the official documentation by the authors, look. Let me help you a little bit and saying here on top we have the training phase. And here in the second row, we have the inference. And there's a little bit specific going on, so let's have a look at this. So what they did for the training of this API LLM. Easy. So they create here a data set of 1,645 API calls. They go here to TorchHub, to TensorFlow HUB, and they take a lot of API from HuggingFace. The top 20 models, for example, in each domain that I just showed you. Isn't this great? They do this fine-tuning, if you want here, on a Falcon 7B or on a MPT 7B. Beautiful. So they have now this information in a JSON file, but they have not enough for the fine-tuning process to be on a high quality level. As I told you, fine-tuning, you need thousands to 10,000 pairs minimum for the fine-tuning to be really efficient. So what they do, they say, okay, so we have 1,600. We want to have 10 times as much, so 16,450 pairs where we have an instruction and the API. So what we do, we go to GPT-4 and we ask GPT-4 with our 1,645 to generate syntactic data. And we have 1 and we create 9 additional syntactic data where we get the instruction for the APIs that we have defined in the system. Isn't that beautiful? And this then is used for the fine-tuning here of the Falcon 7B model. And now with the fine-tuning, it becomes now the Gorilla-7B model from UC Berkeley. This is here the fine-tuning of the model, and we get an additional benefit. All our data set that we created, we can create a database. And in this database, we have all the API information that we need. Great. Now the inference. I have in inference a simple natural language job description for GPT-4. I want to see some cats dancing in celebration. Now I have 2 options. First option is zero-shot inference. So this means I have my natural language task description. GPT-4 gives this now directly to Gorilla. Gorilla has been fine-tuned on this particular API job only and says, okay, if I get this, I return this API information. Stable diffusion pipeline from pre-trained stable diffusion to 2.1, for example. And this is the API to create then the result. Or, and this is the second option that the authors of this research paper proposed, since I have here this API database, and this database, remember, I can update this database, I don't know, every week, every month with new API information that is available on HuggingFace. If a new model is published on HuggingFace or on TensorFlow or on PyTorch HUB, this database will be updated regularly. So I can have now here, in addition to my natural language prompt task description, that I ask the database to come up with the, I don't know, top 3 or top 1 additional augmented data information I can input in the prompt. So I do not have any more zero-shot, but I give it, for example, 2 or 3 examples in addition in the prompt for the inference. So you see now the information retriever says now, hey, with this particular task that I asked GPT-4 to perform, now comes out, this is a task that is generate image from text. And we know generate image from text in the database. Remember HuggingFace for the domain, generate image from text. There are, I don't know, 100 of models available. Let's take the top 3 or the top 1 or whatever sorting, filtering criterion you apply here in this database, and you get a reference API, stable diffusion. Yes, yes, yes. So you provide this additional information in the prompt that goes into our API LLM that we call now Gorilla. And this is the prompt that Gorilla comes up now with an API call as a result. This is it. This is all there is to it. You understand now the training procedure, and you understand that using this API LLM called Gorilla in inference mode, you have 2 options. You go either zero-shot or you use here some information retriever to get some additional examples in your prompt. Great. The same in text. Retrieval mode, as it is called, retrieves the most up-to-date API documentation that is stored in our API database, as I showed you. And this information is then concatenated to the user natural language prompt with the message before feeding it into our, I don't know, Falcon 7B Gorilla LLM. The output of Gorilla is an API to be invoked. Let me show you an example of this. Here in red, this red indicates our user prompt. And then we have here the assistant. So as a user, I say, hey GPT-4, our customer is a zoo, and we want to help them detect movement of different animals. please write a Python program, 1 or 2 lines, to call an API in the TensorFlow HUB. So I want to operate here with TensorFlow 2, for example, or whatever TensorFlow version we have. Give me the code. And the system comes back and says, hey, great, I found in the TensorFlow HUB that you specified, in the domain image object detection, I have here a specific API call. And there I say hub load. And then I have here a specific Google methodology, SSD, MobileNet version 2, whatever. And I have an explanation. This API call loads the pre-trained single-shot detector. Now I know what SSD is. MobileNet version 2 model from the TensorFlow HUB, which has been trained on the open image dataset. This model is used for object detection in images. Once loaded, you can pass an image, hey, an image and an optional SSL to the detector and get back to detected objects, along with their bounding boxes, their class labels, and their associated confidence scores. This is great. This is exactly what I need. And I get the code, and I take this code and I put it in my TensorFlow environment. And I just say copy, import TensorFlow as TF, import TensorFlow HUB as HUB. Load detector, yes, yes, yes. So just copy the code. This is the zero-shot example. If you have a user prompt, what you get back from our API LLM, our Gorilla. Second option, as I showed you, with the retriever info added to the prompt. So we get an augmented prompt structure that we put now to GPT-4. GPT-4 forwards it to our API LLM, to our Gorilla system. In red, you have now the input prompt. So I say, hey, I'm an engineer at Uber, and I need to find an API that can classify pedestrians, cars, and other objects from an image of a scene. Write a Python program in 1 to 2 lines to call an API in PyTorch HUB. So we're working here in PyTorch, PyTorch 2. And now this is the augmented API documentation that I get now from my API database. And I provide here this example to get here a better informational augmented prompt. What I get back is exactly this one. I say, okay, my API provider is PyTorch. My explanation, I load a pre-trained hybrid net object model for object detection from PyTorch HUB to classify pedestrians, car in an image of a scene. The code is import torch model hub load. Done. So you see, there's a lot of additional information, and the creators here of this methodology thought that this would improve everything significantly. And interestingly, they say that we find, the authors say, that augmenting an LLM with the retrieval does not always lead to improved performance. And sometimes adding this additional augmented prompt information can hurt the performance of the system. And at first I didn't get it and said, why? Yeah, imagine you have the fine-tuning phase of this API LLM. And the system finds a particular solution. And then you get additional information from the API database. And those information are not perfectly coherent. If they are divergent data, you can hurt the performance of the overall system. So I think this is a very interesting point. I have to experience with the system a little bit more to get really an understanding, but beware, adding more information on a very good fine-tuned model is not always the best and recommended way to get improved performance. What I forgot to mention, paper concludes emphasizing the importance of the ability to changing API documentation. Whenever you update here the system or your API database, you can have a rapid pace of updates in the API documentation. And since the system loads here the latest API documentation here for this augmented prompt structure, all the updated information should be available, which leads us to another point. If you have updated information to a perfectly fine-tuned API LLM, at what time does the updated information overrides the inherent knowledge that an API LLM holds, and what are the hyperparameters you have to optimize your system for. But this is in detail, not for this video today. I just want to show you this is how here this code system works for specific API LLMs. And now you have an idea how on GitHub or Microsoft bought GitHub, the Code AI assistant works. Very similar. What else? Yes, if you want to experience Gorilla yourself, go to Gorilla CS Berkeley Edu. You have there the Colab notebook I showed you at the very beginning. You have the complete GitHub documentation. You have the scientific archive preprint that I showed you. You have a Discord server, so everything is here. You have here an API App Store for LLM with this new Gorilla by UC Berkeley, Microsoft Research, and for me, yesterday, Microsoft came out, or GitHub came out, and told you, hey, the new GitHub AI Assistant for coding is available now. So there you have it, a new large language model specifically for the task to connect with massive APIs done by UC Berkeley and Microsoft Research. So Microsoft Research has here, if you want scanned here, their complete API functionality and everything on HuggingFace, on TensorFlow, and on PyTorch HUB. And if you wonder, hey, why did this team did not go and here scan also GitHub? Because on GitHub there are a lot of AI models independently, if it's for natural language or vision transformer, audio, or any other thing. Now you know the reason, because as I showed you here, GitHub has its own commercial product now out in a beta version for companies. GitHub is owned by Microsoft. And now you know exactly why here this system of expert that trained here did not in this particular study include the GitHub AI models and the GitHub AI data. I say thank you for listening, thank you for watching. I hope there was some additional information for you to think about where you will publish your next free code sequences. And I wish you a beautiful weekend. Hope to see you in one of my next videos.